In this video, we will discuss some SAS functions. SAS functions are essential tools in data programming. Roughly, the functions can be classified into three categories: numerical functions, character functions, and miscellaneous functions. In this video, we just focus on numerical functions, such as truncation functions, functions to compute descriptive statistics, mathematical functions, probability functions, and random number generating functions. So the first function is round. Round returns a value rounded to the nearest round-off unit. So this function may have one or two arguments. So if it has one argument, SAS will round the number to the nearest integer. So for example, like the first one, 12.1212, right? So it has only one argument. So SAS will round this to the nearest integer. So the result will be 12. For the second one, it has two arguments. The next second argument, so just tells us how to round the first number, the first argument. Point 1 just asks us to keep a one decimal place. So SAS will round this one to 42.7. For the third one, the second argument is 10. So tells us to round the first number to the nearest tenth. So the result will be 100. Notice, so we put those inside of a data step. So those functions can only be used in data step. And so for SAS, because whenever you want to work with SAS and you need a data set, so even if you want to compute some simple values, so like those, so you have to create variables, so like what I did, right? So x1, x2, and 3, and so assign the value to those variables. And so then use print to display the value. So let's run those in SAS, right? So this one, so this is the result as I explained in slides. Second one, we have three closely related functions, so int, cell, and floor. So int returns the integer portion of the argument. So cell just like ceiling, right? So returns the smallest integer greater than or equal to that argument. So floor returns the greatest integer smaller than or equal to that argument. So let's look at these examples. So I input x, so x can be 1, 2, 3, 4, those 4 different values. Basically in this data set we will have 4 observations. So then I just apply round, cell, and floor, and int to those. You can see, so when you use round, so round just return to the nearest integer. So see, so 1.2, so we round to 1, 1.8 rounded to 2, right? So this rounded to minus 1, minus 1.2, 1 minus 1.8 rounded to minus 2. So this just rounded to the nearest integer. So cell, so this is the smallest integer, so greater than that value, right? So when it is 1.2, see, the smallest integer greater than that will be 2, right? See, 1. So cell, so this just means round up, right? So just round up. Okay. So 1.8 round up to 2, right? So minus 1.2 and minus 1.8. So both of them will round up to minus 1. Floor just means round down. Okay, so just it is the largest integer smaller than that value. See, 1.2 will round down to 1, 1.8 round down to 1, right? And so both minus 1.2 and 1.8 will round down to minus 2. So int, so just choose the integer portion of the number. So you just drop, so everything after the decimal point. Yeah, so then the result will be 1, 1, minus 1, and minus 1 respectively. Yeah, so we can check this in SAS. So this is, yeah, so looks like that. Okay, yeah, so the result is as what I showed you in the slide. SAS variable lists. A SAS variable list make it easy to refer to a list of variable names. We can always to write the name just one by one, just list them and separate them by space, right? Yeah, but sometimes, so if you have too many variables and so you want to have a shortcut to list them, right? So numbered range list, so you just use 1 minus. Yeah, so for example, like this one, you can see for these 4 variable names, so they're similar, right? Yeah, because they begin with x and followed by 1, 2, 3, 4. So then you can just say x1 minus x4. So SAS will know. Okay, so what you mean is x1, x2, x3, and x4. So similarly, for these scores 11, score 11, score 12, up to score 15, right? So then you can say score 11 minus score 15. Yeah, so then SAS means you want these 5 variables. The next one you can use is name prefix list. Yeah, so you just write a name prefix and a column. For example, so you say sales column, right? So then what you mean is, so then for all variables, so starting with sales in your dataset, right? For example, so what's after that can be sales January, sales February, sales March, right? So everything starts with sales. Yeah, so this is convenient. So if your variable name start with some prefix plus some characters, yeah, but not numbers. You may also have some special SAS names like this one. See, instead of using 1 minus, right? So you use 2 of them. So this just means all variables from this variable to this variable. Yeah. So what does this mean is, see, this example essentially comes from this data, the baseball data in the SAS help library. If you run this one, I use print. So then you will be able to see a list of all variables and all observations. So what I want is see from this variable, let me see, n at bat to n outs, right? See, n at bat is here, n outs is here, right? Yeah, so what I mean is, so I want SAS to show from this variable to this variable. Okay, right? Yeah, for example, if you say proc print data is SAS help baseball, right? So in the var, so you just say n at bat minus n outs, right? Yeah, so then SAS just will show, see, from n bats to n outs. What's this one? This just between these 2 minus, and so you add numerical. Yeah, so this just indicates all numerical variables from this variable to this variable. If you look at here, from here to here, most of them are numerical. Yeah, but see, this league, division, position, clearly, so they are character variables, right? Yeah, so if you add a numerical, right, so just means all numerical variables from n bats to n outs. See, so this is the output. Of course, so you can also say all character variables, right? So then I just write character. Yeah, so all character variables are between those 2 variables. Okay. And what's others? Okay, so you can say underscore numerical underscore. Yeah, so this just means so all numerical variables in your data set. Yeah, so you just say underscore numerical underscore, right? So then SAS will display, so all will pick all numerical variables in your data set, right? So this can also be changed to all character variables. You say all character. Okay, right. And the last one, you can say maybe all variable. You just say underscore or underscore. Yeah, so this means all variables. Of course, so if you want to print for all variables, and so you don't need to this var statement, so you just directly run in this way. So SAS will display all variables. Okay. Yeah, so those are just some commonly used variable lists. So then we discuss some descriptive statistics functions. Sum, mean, minimum, maximum, so they can calculate the sum, mean, minimum, and maximum of some variable. For example, so if you say sum x1, x2, x3, x4, right? So basically you just compute the sum of those. Okay. And you can also use the SAS name list, right? So you say x1 minus x4, just means those four variables. In this case, if you want to use the name list, make sure to add a off. Yeah, so in here, right? So then this just means you want to compute the sum of x1, x2, x3, and x4. And if you forget to write the off, so if you write it in this way, see, then SAS will think you want to compute x1 minus x4, right? So this off is very important. Yeah, so then you can use all other type of name list, right? You can see off sales. Yeah, so then SAS will just add the summation of all variables begin with sales. Largest, yeah, so this just returns the r's largest value. Yeah, so for example, so largest 1 comma of x1 minus x10, right? Yeah, so then this just means returns the maximum out of these 10 variables. And so if you say largest 2 comma of xq1 to q10, just returns the second largest value. So notice for those descriptive statistic functions, so they apply to those variables for each row separately. Okay, yeah, so apply to each row separately. Let's check the example here. You can see, so I just input the x1 minus x4, right? So this just means I want to input four variables. Okay, and so see, I just use the sum, so I can do the sum of all of them, sum of basically use the name list, right? So this is another way to write the name list. Yeah, so I want this one. Okay. I remember, let me check this if it is true or not. Yeah, so this is true. See, what's the difference? So here, for the sum one, of course, you can see x1 plus x2 plus x3 plus x4, right? And so what's the advantage of this sum function as this one? The difference comes with, so if you have a missing value, see, if we run this one, you can see sum 0 is missing. Yeah, just because for these four numbers, and so one of the value is missing, right? So if you use this plus, right? So anything plus a missing values, the result will be missing. But if you use the sum function, yeah, so SAS will automatically ignore so those missing value. Yeah, so see, for this sum 1, right? So SAS just compute the sum of x1, x3, and x4. SAS ignore, so this missing value x2. Yeah, so this is the advantage of sum function over this summation. Well, so some mathematical functions. So here I just list some commonly used mathematical functions. So ABS means returns absolute value. SQRT returns square root. EXP returns exponential. And so log, so this is the natural log. Yeah, so just means the base is this constant e. And log 10 returns the logarithm with base 10, right? Yeah, so constant just returns some constant. Yeah, so let me show you the example here. See, so if you want the value of pi, right, you can say constant. So within here, so a quotation mark, right? So then you say pi. So then SAS just return the value of pi to this variable. Yeah, and also for the constant e, right? So if you want it, you can do like that. So then we computed the logarithm of e, the log 10 of 10. Yeah, so see, then the result should be 1, right? Yeah, so then compute the exponential of 1. Right, okay. Yeah, see, this is the value of pi, this is e, right? Yeah, so these two values are 1. Well, so then we may have some probability function. So in statistics, you may need to use many distributions, so such as normal distribution, t-distribution, f-distribution, and chi-square distribution, right? Yeah, so CDF just returns the CDF of a distribution. So first it will have we need to specify name of the distribution. So after that, so followed by the value and by the parameters. So notice, so CDF is the probability to the left of a value. Yeah, so just corresponding to this shaded area. Yeah, to the left. PDF just returns the PDF, just the density of a distribution. The probit returns compute the quantile of normal distribution, of standard normal distribution. Yeah, so T-inf just compute the quantile of T distribution. So this is F distribution. C-inf means the chi-square distribution, the quantile of chi-square distribution. So let's show you some example, like this one. See, CDF, so distribution is normal, and so the value is 1.04. So this just computes the probability to the left, smaller than or equal to 1.04. So if you want the probability to the right of a value, so you can use 1 minus, so this probability. Yeah, so in most cases, so if you want to compute p-value in statistics, right? So that's the probability to the right of a value. Probit, so this just compute the quantile of a standard normal distribution. Yeah, so the 0.95 quantile of standard normal. We run this one. Yeah, so then this just gives you the value. So this is an example for T distribution, right? So CDF. So this is just the probability to the left of 3.743. 747. So this 4 just indicates the degrees of freedom for T distribution. So then you use 1 minus this one, just gives you the probability to the right of this value, 3.747. Okay, so this just gives you a quantile of T distribution with 5 degrees of freedom, right? So second argument, so this is degrees of freedom. Yeah, so we can run that. Yeah, so then you will know how to compute those probability. So this is F distribution. So the name of the distribution is F, right? So then this is the value. So for F distribution, we have 2 degrees of freedom. Yeah, so sometimes we call them numeric degrees of freedom and denominate degrees of freedom. So here I just compute the probability to the right of 1.54. Yeah, so for a F distribution with 12 and 10 degrees of freedom. This is to compute the quantile, right? So with degrees of freedom, so 10 and 30. Okay, yeah, so this one. This is quantile, chi-square distribution, right? See, chi-square, okay? And so this is the value, and so this is the degrees of freedom. Yeah, so for chi-square distribution, we have only one parameter, that is degrees of freedom. So this here, I compute the probability to the right, yeah, to the right of 19.68. This one Cinf, I just compute the quantile of chi-square distribution with 10 degrees of freedom. So run this one, so then you will get the value. Okay. So the last one, random number generating. So this function is needed, yeah, so in many programming tasks, and particularly so if you want to do a simulation, right? So you may want to randomly generate some number. So this is very useful. So RANUNI, see, RA means this is RNA means random, UNI uniform, right? Yeah, so it will generate a random number, so uniformly between 0 and 1. So first, I want to say, so SAS does not really generate random numbers, yeah, because those functions are computed based on some deterministic function, yeah. But however, so the behavior of those numbers looks like random. So this is why we call it a pseudo random numbers. Yeah, so they are not truly random. Yeah, but because they are computed based on some algorithm. Yeah, so computer cannot do random things. Yeah, but the algorithm is well designed such that the number computed looks like random. Okay. So in order to get the computer started, so you need to provide a seed number. Yeah, so seed number, so this is just, so basically, so it tells us where to start. A seed is a very large, so usually, so seed is a very large integer, right? So basically, so if you specify the seed, okay, so then every time, so then you run the program, so SAS essentially will generate the same number, okay? And so if you use seed as 0 or maybe any negative number, so SAS will use the computer clock to supply seed, okay? So what I mean is, see, look at these two examples. So the first one, see, I run x1, so then use the RANUNI, this function, the seed is 0. Yeah, but for this one, so I use a very large integer, so as the seed. So if I run this one, so see, remember this number, okay, so 0.3 and 0.5. If I run this again, 0.6 and 0.5, right? See, if you use this seed, right? So then every time, so you run this function, essentially it produces the same number, right? Yeah, but if you use the seed as 0, so then SAS just use the clock, the computer clock as seed. Yeah, because every time, so you run the program, so definitely at a different time, right? So then, because the seed will be different, so then the number generated will be different. Okay, so this is the how to generate random numbers.